Why are we using accelerometers to show the effects of objects in free fall and show the effects of actual acceleration in any other direction, but when sitting on the ground, they're wrong, they're reading at constant velocity? Why the special pleading? I've been told over and over that there's no way the Earth could be moving up at a constant rate of acceleration because weight would continuously increase.
Don't agree when Jason says that constant acceleration would not increase the weight. I think he's wrong there. I've seen his demonstrations. It seems rather limited.
So the reason why I don't buy these experiments from the accelerating earthers, I think his name is Jason. Am I mistaken? I think it's the Rising Earth channel. In my opinion, these experiments that they're showing of acceleration versus constant velocity, and the acceleration shows an increase in weight, in my opinion, those are parlor tricks. Why? I want to see an experiment of the claim, which is something accelerating 22 miles per hour every second, and show me the weight not increase. So for example, from 0 to 220 miles an hour in 10 seconds. Show me that experiment of something accelerating at from 0 to 220 miles per hour in 10 seconds without an increase in weight. Then I will give some merit to these experiments. Until I see that experiment, any other experiment, in my opinion, is just a parlor trick. Does physics scale? Yeah, when we're talking about relative speeds, like if something decelerates relative to a certain speed.
Your weight is simply the amount of force it takes to accelerate you, or your resistance to that force. Newton's second law of motion gives us the formula for how much force is required to accelerate an object. F equals ma. Force equals mass multiplied by acceleration. So the greater the mass of the object, or the quicker you try to accelerate the object, the greater the force that is required. Newton's third law states that, for every action there is an equal and opposite reaction. So the inertial resistance to the force required to accelerate you will be the exact same. Your weight is simply this same measure. It is the amount of force it takes to accelerate you. W equals ma. Weight equals mass multiplied by acceleration. Is it just the same as g-force? The numbers are expressed differently, but it's all the same F equals ma principle.
Let's see if these demonstrations correlate to Newton's second law. First, we have a mass of 600 grams. According to Newton, 600 grams multiplied by the acceleration of 9.8 meters per second squared equals 5.88 newtons of force. When I accelerate the mass, it goes up to 700 grams, or 6.86 newtons of force. It stays at that mass all the way up. If I put this into the formula and divide the 6.86 newtons of force by the original 600 grams of mass, I get a total acceleration of 11.43 meters per second squared. I must then subtract the original 9.8 meters per second squared from this 11.43 meters per second squared to get a 1.63 meters per second squared acceleration for the test. What this shows is that the demonstration had an added constant rate of acceleration of 1.63 meters per second squared, making the 600 gram mass increase to 700 grams. Well, you might be like me and think, oh, that's just math magics. Math can be made to describe anything. How can we test this? How can we see if this demonstration is accurate? How can we see if these numbers add up and line up? Well, we know that what the acceleration rate was 1.63 meters per second squared. We know the height of the test, which was 22 feet, which was the same as like 6.7 meters high. We can see how long it would take to accelerate something from 0 to 6.7 meters high at an acceleration rate of 1.63 meters per second squared. If we plug those numbers into the formula, we got 1.63 meters per second squared with a height of 6.7 meters. It should take approximately 2.24 seconds. Let's see what the test shows.
parlor trick. It's just a parlor trick. It's just a parlor trick.